third problem is found on page 32, number 3. So the problem states that determine if the function fxy equals x to the 1/3 y to the negative 2/3 arctan x over y is a homogeneous function. So by definition, f is said to be a homogeneous function of degree alpha if it possesses the property f tx ty equals t to the alpha times the original function f x y for some real number alpha. So what we're going to do now is we're going to transform this function to f tx ty. So f tx ty is equal to tx to 1/3 ty to negative 2/3 and arctan t tx ty. Since we cannot factor out t from arctan, this is not a homogeneous function.
The fourth problem is found on page 38, number 29. The problem states that find the general solution of the differential equation y equals xy prime plus 1 over 1 plus y prime. We will let p equal to y prime, which is equal to dy over dx. So the equation would now be y equals xp plus 1 plus p to the negative 1. Differentiate both sides of the equation with respect to x, and we will get dy over dx equals x dp over dx plus p minus 1 plus p to the negative 2, 0 plus dp over dx. So take note that p is equal to dy over dx, so this will cancel out and we will get 0 equals x dp over dx minus 1 plus p to the negative 2 dp over dx. Factor out dp over dx, so dp over dx times the quantity x minus 1 over 1 plus p quantity squared.
So from this, we have dp over dx equals 0 and x minus 1 over 1 plus p quantity squared equals 0, which we will solve later on. So first we have dp over dx equals 0. We will integrate both sides with respect to x. So we have p equals c, which is an arbitrary constant. So now that we have p equals c, we will substitute c to the original equation. So now we can substitute this to y equals xp plus 1 over 1 plus p to get the solution. So this will turn out xc plus 1 over 1 plus c. To verify that this is one of the general solution of the differential equation, y equals x y prime plus 1 over 1 plus y prime, we will differentiate both sides with respect to x. So dy over dx, which is equal to y prime, is equal to c plus, this is equal to negative 1 plus c to the negative 2, 0. So our y prime is equal to c. Then we will substitute this to here. So our y is equal to xc plus 1 over 1 plus c equals x, y prime is equal to c plus 1 over 1 plus y prime, which is also equal to c. So we can observe that both of the equations are equal. So this proves that this this equation is one of the solutions of the differential equation y equals x y prime plus 1 over 1 plus y prime. So now we will solve for the other solution, x minus 1 over 1 plus b quantity squared equals 0. Transpose, we will get x equals 1 plus b quantity squared, multiply both sides by 1 plus b quantity squared over x, and we will get 1 plus b quantity squared equals 1 over x. Square root both sides, we will get 1 plus b equals 1 over square root of x. So transpose 1, and we can simplify this further. So p is equal to 1 minus square root of x over square root of x, and p is equal to negative 1 minus square root of x over square root of x. Substituting first, p equals 1 minus square root of x over square root of x. We will get y equals x times the quantity 1 minus square root of x over square root of x plus 1 over 1 plus quantity 1 minus square root of x minus square root of x. You can simplify this further to get y equals square root of x minus x plus square root of x, or this is just equal to 2 square root of x minus x. To verify that this is one of the solutions to the differential equation y equals x y prime plus 1 over 1 plus y prime, we will find the y prime from this solution. So differentiate both sides, we'll get y prime equals 2 over 2 x to the negative 1/2 minus 1. So y prime is equal to 1 over square root of x minus 1. So y is equal to 2 square root of x minus x. So y is equal to x y prime, or y prime is this one, 1 over square root of x minus 1 plus 1 over 1 plus 1 over square root of x minus 1. We will simplify this, so we will get x times 1 over square root of x is just equal to square root of x minus x plus 1 over 1 minus 1 is just 0, so we get 1 over 1 plus square root of x, so this is just equal to square root of x. Then square root of x minus x is equal to square root of x plus square root of x is equal to 2 square root of x minus x, and both of the equations are equal, so this is one of the solutions of the differential equation. Next is p equals -1 minus square root of x over square root of x. So same as what we did with the previous solution, we will substitute this to p, x times p, which is this one, plus 1 over 1 plus p. Can simplify this further, so we get negative square root of x minus square root of x, and this is just equal to -2 square root of x minus x. So to verify that this is one of the solution of the differential equation y equals x y prime plus 1 over 1 plus y prime, we will find the differential of this solution. So y prime is equal to -2, differential of square root of x is equal to 1/2, then x to the -1/2, and differential of x is just equal to 1, so this is just equal to -1 over square root of x minus 1. So after this, since our y is equal to -2 square root of x minus x, we will equate this to the original differential equation, xy prime plus 1 over 1 plus y prime. So y prime is this one, plus 1 over 1 plus y prime, we will get this is just equal to negative square root of x minus x plus 1 minus 1, 0, so we have -1 over square root of x, so this is equal to -1 over square root of x, or -2 square root of x minus x equals square root of x minus x minus square root of x, or 2 square root of x minus x equals -2 square root of x minus x, which proves that this equation is one of the solutions of the differential equation y equals xy prime plus 1 over 1 plus y prime. To sum it up, there are 3 solutions of the differential equation y equals x y prime plus 1 over 1 plus y prime. So these are y equals xc plus 1 over 1 plus c, or y equals 2 square root of x minus x, or y is equal to -2 square root of x minus x.